And inside this, there is a lot of repo with, during my PhD, I worked essentially with images, so medical images, natural images, and all of this, in all of those repo, there is contain either DICOM, PNG images. So when I want to do the actual binding, I will directly use those repo. I will link the exact absolute path inside the cluster of this repo, and I will show you what to do this.
So that means I couldn't use your image.
You can use my images and my dataset.
In
you can read.
In my PC or in the cluster.
In your PC, you cannot, but in the cluster you can.
Okay.
So in the PC, when you do the binding, you will only do the binding in your local environment. But from the cluster, you can have access in reading mode to all the other machines. So now let's copy the image. So that's copying. Since the file is quite large, maybe 1 or 2 gigabytes, so taking it's not like immediate, because the more you use packages, the more you install, the more you add, the larger the image becomes. So in our case, it's 1.75 gigabytes, the zip file. And now, if I'm coming back to containers, you will see that I do have inside it something that is called workshop. That's it. Workshop new. That's it. As you can see. Okay. And now what I can do is basically I can now run script inside the cluster, and I will show you how you run a script inside the cluster. And to do it, just let's come back to the presentation very quickly. And what you do is basically you create S-batch file, which first have the following configuration, and then some call to the singularity images that I will show you the exact form, but all your S-batch file should have something like this. You should have first some configuration that are based on your job, what it needs, which type of it needs GPU or not, if it needs how many CPU it needs, how many memory it needs, and so on. But this is you can see all the specific configuration inside the the Slurm configuration page. They have a great documentation. And inside the slide, I have added like the most popular flags that you can use in your configuration. So most of the time you will be using this inside your configuration. And to run a job, what you do is basically you type sbatch, the name of your Slurm file. That's it. And then the code will be run. That's very simple. And now I will be showing you how to run this. And we will skip those use cases because we do not have that much time now. But I will show you use case with like a CPU and GPU. So as I mentioned earlier, what we do is basically we connect with SSHFS, and then we can like open a terminal and directly walk inside with the GUI, and it is typically what we want to do. For some reason, cannot have access now. It's like the PC is weird. No, not the screen.
So you can have that in Visual Code as well. So that is, I think,
Yeah.
simpler.
So normally what you can do is you can directly open terminal. It's not working, I don't know why, but yeah. So now I can open VS Code. Let's open somewhere else. Yeah, so now this is the version of the code inside the cluster. Okay? And now what I want to do is I want to run those, for example, scripts. And to do this, for example, if I want to run this in the cluster, if I want to run this in the cluster, what I will need to do is basically use this script. This script is very simple. So let me show you. In our case, it was something that I copy paste from previous runs. So basically what you do is you add your configuration simply, and you type srun, which is based on Slurm, which basically will run a command, which is singularity in our case, singularity, exec, and what we did inside our PC, basically. And I have like added 4 demos, one demo for CPU alone, just for one job, CPU with array to launch multiple jobs with CPUs, and the same with GPUs. Okay? So now let's start with the simple one. So the CPU single. So we just want to run a simple CPU, CPU. For now, we would delete the bind. I will show you how to use the bind later. So basically, we type srun, singularity run. Maybe I should augment.
Yep.
Is this okay? Yeah. So I'm telling that I want to run this in the partition server CPU. As I mentioned earlier, when you do it, you can write and see when you connect it which type of partition it is available and what is the name. So let's connect in SSH. So yeah, maybe it's like 83. Yeah. So once you use like this command many times, you will be able to remember half of it. So Now, to do the next part, I need to be connected and be placed inside the HPC workshop. So I will just cd inside it. And when I tap, I see all the script. Okay? Now, what I do is basically I will create two other things. So the first one is log, which will contain all the log file that will be generated by the running the script. So basically, the output of the script will be inside the text file. So if I have error or if the script is running correctly, I will see what is happening. Okay. And now what I do is basically I will just run the script with the correct images. So my images is not called Carpio image but workshop new. And as I mentioned, I do copy the absolute path. So data GPU error // container workshop new is the exact absolute path inside the cluster. And then what I do is I tap Python, which is my command, and then followed by the script. Okay? And in our case, the script is called CPU single. And now if I run s batch followed by the actual sh file, which is s batch CPU single, I will be able to run this job. Okay, so now if I run, it will say Slurm will tell me that I do have here an error, but it will submit the job, but it will tell me in the log that I have error. Okay, so let's run the job. Submitted batch, so it's submitted. And now let's see if my job is still running. So since the job was very quick, is in CPU, just what was just 1 second, we didn't have the time to see if it went, but we will see in the log what it gave. So as you can see, we have two files that present the output and the text. The output will be what the script outputted, and the text will present the error that was inside it, if there is error. Okay? So there is nothing. And now what they tell us that the error is the file do not exist. So basically I did a mistake in the file. Can you spot the mistake? Yeah. Can you spot the mistake? I did the mistake on purpose.
So the path is not right?
Yeah. And what should be it? What should be the path?
HPC workshop.
Yeah, exactly. Is missing the workshop inside it. So that's why we always need to put the absolute path inside it. Okay? And now this script, single CPU demo will be run inside my images, and it will give me either an error or it will give me what it is intended to do. And the script is basically this one, single CPU, to just do some basic calculation. That's it.
So every script will give some output in the log folder.
Yeah, you need to place this inside.
Okay.
You have like a S batch single, and as you can see here, I have error and output. Okay? Yeah. And every time you run, if it's submitted, in any case you will see what happened. Right. Okay?
Actually, I thought those are just comments that they are included with Slurm, the first part. They're not just comments.
No, it's really actual. It's not comment. It's actually the way that SBatch file are written in for Slurm.
Does that mean we can't make comment to this file?
To make comment, it's two hashtag. So you can like to make comment is like this. So this one will not be taken into consideration, but one hashtag would be taken into consideration. Okay. Next question. So now we rerun. Submitted. Okay. Job is submitted. Now what we do is basically we will look at what the job did. As you can see, job demo, the output, so everything run correct. Okay? Because if you run this script inside your PC, it will give you the same. Okay? So give you the output, and in text it should not be anything because there is no error. Just be warning inside, but it's basically it's like it's some warning, but it linked and related to Slurm and not the code. Okay. So now we will do the same, but with the CPU array. Instead of launching one instance of the script, we'll be able to launch multiple instances. Okay. So it's basically the same. So instead, what we do is we add array inside it. Okay? And what we do is we also change the way that we write the logs. It's not in the single input. We have J and G. We have G, sorry, for just the index. But for the array, we have the ID of the jobs and the index of the jobs. So for example, the jobs can be named 100, and then we have 100, 0, 101, 102, 103, etc., etc., etc. Okay? So let's see in live what it is done. So the same, what we need to do is we need to change the path, that is good. Python, that is good. Here, we just need to change to PC workshop. And this will be, this will create the link with the ID of the run. So just to understand clearly, when you have array this form, so some kind of index 0 to 4, this same script will be run 5 times with different index 0, 1, 2, 3, 4. And it will be changed here. But the same instance of the script will be run 5 times. And the only thing that will change is this argument. That's it. Okay? So let's try it. So CPU array, demo CPU array. Yeah, so I added inside a parser which used the argument task ID to make sure that we will be able to use this. And you will see, so let's cheat a little bit. So here, what I will do is I will watch. So this is not only working inside Slurm, but it's working for every command line in Linux. If you type watch followed by your command, it will update the same command every 2 seconds. So you can kind of see in real time the effect of your command. So I will do watch SQ followed by my name. To see all the jobs that I have, okay? And in the right one, I will launch the array. So you can see that those are coming and then they are going, okay?
Can you tell the name of it? your ID and
Now, watch is not based for, it's based for everything in Linux. If you type watch followed by your command, it will just give you, it will run infinitely your command every 2 seconds. So you can watch, you can basically watch in real time the effect of the command.
okay.
So just loop the command. So for example, for NVIDIA SMI, if you
Yeah.
want to see in real time, you just tap watch NVIDIA SMI and it will give you in real time the updated version. Okay? So we come back to this. And what we do is now, instead of launching the SBatch single, we will launch CPU array. Okay? And everything is the same. We go to server CPU. The name will be CPU array test, as we have cut CPU per task. The memory that we want, it will be 8 GB, and the name of the log will be those one, and I will have 5 instances of the script: 0, 1, 2, 3, 4. Okay, I can have like, let's say, let's be crazy, guys. Let's give me a number.
Then why is the number of CPU 4? Like if there are 5 jobs.
For one job, you can have multiple CPU associated to it.
Oh yeah.
Do they run parallel or sequential? Do they run parallel?
They run in parallel. So let's say I want to run like, let's be crazy, 20. 20 job on CPU, it's okay. I can run hundreds. It's not a problem. Really not a problem. And also, what I can do is I can run on those 20. So technically, if I want to run 20 job, it would be 0 to 19, and it's indexed at start at 0. If I want to run in batch, what I can do is I can type percentage and type the number of batch that I want to run in the same time. So if I want to run 5 jobs by 5 jobs, I type 5, and those will be run to 0 to 4, and then once those are finished, it will run to 5 to 10, and so on. Okay?
Why do you want to do that?
Because sometimes you cannot run, for specifically in GPU, you cannot run like 10 jobs. Because if you run 10 jobs, Jean-François will snipe you. He will snipe you, and then he cannot ban you, but he will he will come and say, oh, what you are doing, and in your case, since you are in EMT, it will just send you an email. But if you are in the native, it will.
Seems like you have a lot of.
Yeah. Many times he came in my office. He was like, "What are you doing?"
But
So-
normally, how many jobs you could?
In GPU, up to 8. I would say it's like the limit.
Okay.
8 in parallel.
At a time, 8 GPUs you can use.
Yeah.
Okay.
8 in parallel it's very nice, and in CPU you can like go to the 50, 100, 50 or 100. I think it's like decent. So let's test, guys. I hope it's working, because all of this I didn't try, just like make sure that the code is working. But since I'm quite familiar, I hope it should work. So the same SBatch followed by the associated SH file, okay? SBatch followed by this one. It will be CPU, not single, but array. And now let's see if we have everything correct. So srun, singularity, exec, data GPU, that is linking our singularity file, and we want to run the Python script that is called CPU array demo. CPU array demo, and we just have task ID, which is basically linking the script. If we want to do something with hyperparameters, for example, it will load a specific configuration linked with an ID. Okay? And now you can see there is 5 jobs, and they went. I can rerun. You will see there is a lot of jobs. They they spawn, and since it's very quick, they're like here for 2 seconds. So be ready, guys. And why there's only 2? Maybe I did something inside. No. Should have 20 of them. Strange.
Yeah, maybe it's not displayed.
But you can see, well, like a lot of jobs. But now, if you see the logs, you will see a lot of logs. You will see, since I ran 3 times the script, you will see like almost 65. And for each one of them, you can see there's like a specific ID associated to them. Okay?
So one tangential question, like how do you manage, like how do you see results if you're like running lots of jobs, and how do you like manage those?
So basically, when you're running an array format, so based on my own experience, what I do is I check out for the script, check the out. But the best thing is, most of the time, is when you're working with let's say deep learning, is to have like some kind of totem board, and then you can link those totem board and then analyze this inside your PC. But reading all of this is quite long. So what you do is, sometimes when the script is ending, you have some kind of pipeline that save the result inside the CSV, and then you can check directly the CSV. Or if you want to look in real time, there is 2 options. You look the out, which is like it's okay, but if you're like 30 or 40, it's like become like very hard to follow. Or you can just have the same, but with like a tons of board, with following all your experiments. So that's basically the 2 things that I do. Either I do the third one actually. I also do the CSV, running everything, and then I save the validation and the test inside the CSV. And then I have a complete picture of the run that I did. Okay. And now what we do is, the last thing is with GPU jobs. And for GPU jobs, since I didn't create an image with GPU, I will use my own machine, my own image that I'm using currently, and we'll just update some stuff. And for GPU jobs, there is 2 extra things that you need to add. Is this --nv, which basically tells Singularity to use NVIDIA drivers. And you need to also add this. The sbatch dress equal GPU. If you do not add this, your GPU work will not work. GPU job will not work. So those are the change. This one and NV. Okay? And obviously, which makes sense, you need to go to a partition where there is GPU. In server CPU, there is no GPU, so it will not work. You need to go to a partition where there is GPU. Okay? So let's run this GPU array script, and it will basically just tell me that it's a simple script that look if torch is here and if there is CUDA. That's it. But this script can be basically anything, guys. It's for demo, but your script can be whatever you want. So yeah, I'm doing some calculation, which I did. Very simple. And the simple also, I think it's doing some calculation. Yeah. So yeah, let's do the GPU. Let's do the symbol first, GPU. So we need to change the name. So we have like it's always a good idea to have like a representative name of your experiment. So since you are working with a lot of experiments, you need to have like log file that means something. Because if not, if you always have the same log file. For example, let's say you do different experiments. You want to like have a real name for all of the experiments, so you are not like lost between all the log file that you will create. Okay, so always try to give a useful name of your experiment. Okay, and in our case, we want to access the partition with GPU that are 40 gigabyte and 11 gigabyte. That's it. If I wanted to have like also the 48, I will just add this, and it will choose randomly what is available and give me the results. But if I just want to have like access to, for example, my job is like taking at least 40 gigabytes. I just want to like this because I just want to access GPU that have at least 40 gigabytes. Okay. And in this case, since the job is very simple, just need like the normal ones. Okay. So now what I do is the same. So what do I do, guys? If you followed, what do I type now?
S
batch, okay. Followed by exactly. You followed. And we are inside the file, and we already made everything. The only thing that we need to make sure is we need to delete this. I will show you what is binding later on. So that's the binding, basically. But now we do not need it. And so data GPU, // container, Cabrio image. That is currently the image that I'm using inside the Docker, the cluster, which with my current project. So I know that there is torch inside it. So that's why I'm using it. And then type Python, followed by the script. That's it. And now, if I run this, you will see that one job will appear on the left. As you can see, it appeared and then disappeared because the job is very quick. Okay? So let's go to the log. Let's see if there is GPU somewhere. Yeah, there is GPU single. Now, same mistake. I do not have the correct path. And as you can see, the mistake is captured inside the txt. The out is for the output console, and the txt is for any error that it is providing. Okay? So here I just need to change and what I do is basically run the same, and this should be working properly. So 5 seconds, just run 5 seconds, that's it, for doing some kind of matrix multiplication. So it tells me that it started like this, that there is one device called 0 at the index, that the name of the device is NVIDIA GeForce RTX 4090, and it gives me some computation that I did inside the script. That's it. Okay? And now I can do the same, but with the array of jobs. For example, if I wanted to run multiple jobs with let's say GPUs, I can do the same with array. And that is what we will do now. So let's run 4, and let's try the same thing, and we need also to update this. The workshop. And now, since I have asked, so let's do it now. So as I mentioned earlier, if I do this, it will be 0 to 3, so it will launch 4 jobs. And if I add percentage, it will launch job 2 by 2. So let's try. to launch 2 by 2, you will see 2 jobs, and once those 2 jobs are ended, it will relaunch the, so it was 0, 1, and then it will launch 2, 3. Okay? So let's see. As you can see, 2, 3, and then when it's done, it will launch the rest. Yeah, so it launched everything. And only thing that we need to do now is to check GPU. So the name of the job was, the ID was 93, 82, 39. Yeah, so that's those one. So first one, ID 0, ID 1, ID 2, and ID 3. That's it. And basically inside the script, what we want to do is, when we basically want to use this task ID that comes from the Slurm ID inside the code here, this variable, we want to use it to configure different experiments. So for example, let's say I am in my script, and let's say I define like a value, let's say batch size, which is not the correct way, but just you understand the principle. And let's say image size. Now, what I can do is, I can have access to it with using the arg task ID, because every time the script will be launched with a different instance, but with a different ID. So if now I do print,
So the IDs go serially, like 0, 1, 2, 3, 4.
Yeah. exactly, and now if I do like and now for each time, typically, this will change. And typically, this, we want to be able to use this inside our code, because we want to use our code for different parameters. And this way of doing, with indexing some specific value inside an array or inside a data frame or inside anything that can be indexable, you can then change the value of your script and your parameters. So now let's check. We will rerun, and we will see that those values change. So it's running. So it ran first 0, 1, and then 2, 3. So 3 is almost done. Yeah, finished. And the name was 83, 42, 82, 40, 43. So yeah, if we check now, out, it will give us something like this. So 2 batch size, 500 match size. Normally the next one would be different, be